let's connect a load to the output of this circuit and talk about that for just a moment. Here I have specified an input voltage of 1/10 of a volt, an input resistance of 1K, a feedback resistance of 100K. That gives us a gain of minus 100. Remember, it's an inverting amplifier, and thus the output voltage is minus 10 volts. Now, let's add a load resistance to this. Here I have added a 10K load resistance. Now that would typically represent the Thevenin equivalent resistance of whatever the actual load was, and that's connected to ground. Now, note that there is 100 microamps through the 1K and thus through the 100K, so you've got 100 microamps heading toward the output from the feedback resistor. You've also got 1 milliamp flowing upward into the output through the load resistance. So that's a total of 1.1 milliamps heading into the output. But now wait, Kirchoff's current law has to be satisfied. So we've got 1.1 milliamps flowing into the output terminal of the op amp. We've got 0 current going into each of the inputs. So we've got a little bit of a problem. Where does that 1.1 milliamps go? Because it's not popping back out of either of those inputs. Now, that brings up power supplies. There ain't no such thing as a free lunch. The op amp has to be powered up. Now, what we usually do not show on op amp circuits are the power supply connections. In our next video, we will talk briefly about how to power up an op amp and what that means. For now, let's just say that 1.1 milliamps in this specific circuit actually returns back through the power supply connections. That's how Kirchoff's current law is satisfied.